Session, guys. Okay, so hey guys, welcome back to Coders Arcade. This is Ashank David, and in today's live session, this is going to be live session number 38. And in this live session, we are going to talk about Dijkstra's algorithm. We were doing graphs before, and in today's video, in today's live session, we are going to talk about graphs, Dijkstra's algorithm, an algorithm which is going to be used for shortest path finding. As you are already seeing it here, we are going to work with this graph today, and you can see that this graph is having the weights onto its edges, and these weights will represent the graph into this. So how you can start from the first node, you can start from anywhere, but here we need some source node. Now it's not fixed, but we are going to see that very soon. Right now guys, we are going to see this in this live session. This is what we are going to learn in today's live session in graphs concept, in graphs Dijkstra's algorithm, guys. So welcome back, and yep, I know we are gonna complete this. So guys, before I start with this live stream, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon also, so that you won't miss any future updates. Now, before I start with this, also I would like to request you people to please share this live stream as much as possible, because this live stream should be available to all the people who really wants to learn DSA, and all of that for free. Without any further ado, let's get right into the concept, guys. And all we know today in today's class, we are doing Dijkstra's algorithm. This is what we are going to discuss. Here today we have a graph, and this graph is the place where we are going to apply the Dijkstra's algorithm. In schools and colleges, students, they call it as Dijkstra's algorithms also. So we are going to talk about that in today's session. So stay tuned, sit back, relax, and let's understand how we apply this. So let's begin. So guys, we have here this algorithm to perform. First of all, why Dijkstra's? To find the shortest path between the nodes. We use the Dijkstra's algorithm. Dijkstra's algorithm. Okay guys, now as I have already told you before, where do we use graphs in real time? You can take an example of Google Maps. In Google Maps, you want to go to some particular place. What do? You just search for that city or a particular place, and then you say start the journey. When you say start the navigation, your map application, your Google Maps, will calculate the shortest distance from city 1 to city 2, or from point A to point B. Which road to take, which road is on which road, how much traffic is accumulated, how the distance will be calculated between two cities. Everything is performed using algorithms like these to find the shortest path between point A to point B. This is the main reason why we use Dijkstra's algorithm for, and in today's live session we are learning this algorithm called as Dijkstra's algorithm to find the shortest path in the nodes. Guys, here the nodes can be saved as in the cities format. For example, you see that we have Google Maps, and in Google Maps it is the collection of various different cities connected or linked to each other using roads. You can visualize this or take this data and put it in a form of a graph data structure like this, where you see that one city becomes one node, another city becomes another node. So like this we have multiple nodes, multiple city, and these are the roads between all those cities. These roads here are in the form of edges in terms of graph. I hope so that you are understanding what I am trying to explain in this class. So here guys, you see that here we have the roads and the cities, or in this case nodes or the edges. I hope so that this is very much clear to all of you. Clear? So in this case we will have something like this. Now ultimately you want to find the shortest distance between any of two nodes or any of the two cities. For that reason you will be applying this algorithm called as Dijkstra's algorithm. People also call it as Dijkstra's algorithm. Well, I hope so that this is absolutely clear to all of you guys. If you have any doubts, or if you are not able to listen to me, I hope so that it is obviously audible. Let me just check the health of the stream. It looks very fine, though I can hear my voice also. Yes. So guys, yeah, so everything looks fine. So in this case I am going to continue. In this case, if you have any doubts or anything, please do let me know in the comment section below, and or in the live chat. I can see the live chat as well, and I'll be able to solve the doubts. Alright guys, let us continue from where we left. Let's continue. So here we have this. Now I need to apply Dijkstra's algorithm and find the shortest path from the, let's say, source node to all the nodes. What will I do? Let us understand. Let us see with some help of some examples here. First of all, what are the requirements? The requirements here are creating an array. Let's call this as distance array. Or you can call it as the answer vector. This is going to be our answer. Okay, this is going to be our answer. This vector will have the same exact size of the number of nodes. So there is 0, 1, 2, 3, 4 and 5. Okay guys, I hope so that this is very much clear. Okay, by default you will store infinity and infinity in all the places. I hope so that this is very much clear. Why we stored infinity into this distance array as of for now on all the nodes indexes? Because we are assuming in the beginning that we have not found the shortest path yet on that particular node. Here each index represents 1111 node in the graph. We are imagining that we have not reached till that particular node yet. That means we have not found the shortest distance yet. So by default infinity is the case. We have stored infinity in the array for all the indexes. Apart from this, what is this you are seeing? This is a priority queue. Okay, why we need this priority queue? We need this priority queue to store all the possible found shortest distance. Here we will be storing the data like this 0, 0. The first data I will store, because you see the first element, the first node is the source node is starting from 0, and here I will be storing 0, 0 representing the distance, the node. Okay, this in this priority queue, this 0 represents the distance and this second one represents the node. As soon as I will find the shortest distance I will store that right here and I will update it in the place of infinity. Alright guys, this is the way that we will be doing it. Guys, I have always, you will put 0, 0 in the beginning or whatever the source node is for you guys. Understood? So, in this case, we have stored 0, 0. Why? Because our source node is 0. And you only think, if you are standing at 0 and if you want to go at 0, what is the distance you will cover? 0 distance. I hope so that this is very much clear to all of you. You are standing at 0. You are standing at 0 right here. Right here you are standing at 0. And you want to reach 0 back again. Because you are standing at 0, you don't have to travel anything. So the distance taken from 0 to reach 0 is going to be 0. And you see here in the distance array, at 0 we have stored infinity. That means to reach from 0 to 0, we did not find anything yet. But now we have found it, that from 0 to 0, it is 0. That is the best path. So here I added that path into the priority queue. In this priority queue, I have added 0 as the distance taken from the node 0 to reach node 0 itself. Understood? And this is a priority queue. Why the hell I need a priority queue? Specifically, I am going to use heap data structure. Heap data structure, heap priority queue, heap PQ. Heap priority queue I will be using here. Why? Priority queue can be used of any type as you want. Guys, in this example, I just want to explain that priority queue is the major thing which needs to be used. Why? Because as soon as you will find a small path or a new path, you will store it in that priority queue. And according to the priority queue, whichever will be the shortest path, that will be resolved first. And hence, promoting the idea of finding the shortest path first. I hope so that this is very much clear to all of you. So this is the reason why I have created this priority queue. And in the beginning, very first beginning, I stored the source to source node indexes, the distance and the node in this priority queue. Right here, if you see, look at this, you see that from 0 to 0, it takes 0 steps, it takes 0 distance to reach, and so you can update 0 right here by cutting down that infinity. Why so? Because you see, you've already have found a new path. As soon as you found a new path, from 0 to 0 it is 0, you know that 0 is better than infinity. So you will replace that infinity with 0, and this is your first answer into this distance vector. So you see, from 0 to 0, it takes 0 distance, and as soon as I found this path, I added this into the priority queue. First iteration, our preparation is over. Now we can actually start the iteration, guys. I hope so that this is very much clear to all of you. On the other hand, guys, not only this is only the requirement, but also I want the adjacency list also. So let's create the adjacency ADJ list. Now guys, till now, in all the concepts which I have been discussing about, in the graphs, those were the graphs where I have not provided any weights. But now you see, I have weights in the specific area of the edges in the graph. So to create an adjacency list out of it, I would require to write the node index 0, then 1, then 2, then 3, then 4 like this, then 5 like this. I will note down all the indexes, and now what I will do is I will start. Now see, look at this and tell me, from 0, who is the neighbor of 1? 0, 1 and 2, 1 and 2. So you will open up a curly braces, you will say 1, comma, what is the distance to reach that 1? The distance is 4. So here you will say 1 comma 4 in one flower bracket like this. Understood my point? Which tells us that in the adjacency list of 0, To reach 1 we need 4 distance, we need to travel 4 distance. I hope so that this is very much clear to all of you. Then where else we can go? We can go till 2. So for 2 also the distance is needed is 4. So our next point becomes 2 comma 4. To reach distance, to reach the node 2 we need 4 as the distance. I hope so that this is absolutely clear to all of you. Speaking of next, these are the only 2 neighbors in this case, correct? Now speaking of the next one, 1. To reach from 1, where do all we can reach? We can go towards 0 and we can go towards 1. So we have 2 more. To reach towards 0, I need 4. So I'll say here 0 comma 4. Am I correct? You have understood this guys really well? Yes or no? Next is to reach 2, I need 2 distance. So here I'll say comma 2 comma 2 like this. I hope so that this is absolutely clear to all of you guys. Clear? Next, we have to write for 2. So I have given some space here so that I can write more, because as you can see 2 is the node which is going every single place in between. Okay. So here 2 can go towards 0 also with a distance of 4, 2 can go towards 1 also with a distance of 2, and so on many places with some distances. So there will be how many? 1, 2, 3, 4, 5 pairs that we will be creating in the flower brackets to do this. So I'll say 2 can go 0 with the distance of 4. So 0 comma 4, 0 comma 4. So 0 comma 4, then we can go towards 1 comma 2. Okay. We can go towards 1 comma 2, then we can go towards 3 comma 3, we can go towards 3 comma 3, 3 comma 3, then where all places we can go towards 4 comma 1 and 5 comma 6, 4 comma 1 and 5 comma 6, 4 comma 1 and 5 comma 6. These are for the 2. Okay guys. Now let's look at 3. When we look at 3, you see from 3 we can go towards 2 and 5. So 2 comma 3 and 5 comma 2, 2 comma 3, 2 comma 3 and 5 comma 2, 2 comma 3 and 5 comma 2. Then we have 4. So 4 can go towards 2 comma 1 and 5 comma 3, 2 comma 1 and 5 comma 3, 2 comma 1 and 5 comma 3. I hope so that this is absolutely clear to all of you. Okay guys. Then last 5. 5 can go towards 3 places, 3 comma 2, 2 comma 6 and 4 comma 3. So first 2 comma 6 I will write. 2 comma 6, 2 comma 6, 3 comma 2. 2 comma 6, 3 comma 2, 2 comma 6, 3 comma 2, and then I will write 4 comma 3, 4 comma 3, 4 comma 3, 4 comma 3 guys. I hope so that this is very much clear. See, now on the right hand side we have the adjacency list also clear. Anybody has any doubts, please do let me know in the chat below, and I will be able to solve their doubts. Is that clear to all of you guys? I believe so. Okay. Now in this case, this is how it is looking like. The whole board is filled with the things. Now you see here. Now you see here. Now we will start understanding and solving this problem. We have all the things left. We have all the things started. Now you see that I will wait. So here we were, correct? Yeah. And now you see here, we will start from 0 because you are standing at 0. You know that from 0 to 0, it is 0. You found a new path, you pushed it into this and you updated there in the distance array. That is fine. Okay. So you removed this and you said okay. Now if you do this, draw this diagram from 0, where you can go from 0 you can go towards, let us check it out. From 0, we can go towards 1 with a distance of 4, 2 with a distance of 4. 1 with a distance of 2 and 2 with a distance of 4. 1 with a distance of 4, yes, not 2, correct. Let's not draw this actually here because it's not working, guys. I'll see the adjacency list and I'll say, okay guys. Alright, so now you see here, we will trace it, okay. So from 0, you found at 0, 0, so we cleared it and now you see 0, what is stored at 0? 0 distance is stored at 0, okay. From 0, where do you can go? You can go towards 1 with a distance of 4 and you can go towards 2 with a distance of 4 again. Okay guys, so now you see, you are standing at 0, you want to go to 1, you are going to 1, whose path you don't know right now. So you said that there infinity is getting stored, you said okay. So now if I travel from 0 to 4, how much it will take? 0 plus 4 distance, which is equals to 4 distance. 4 distance is better than infinity on 1. So we removed it and I said 4 right there. Hope so that this step is very much clear to all of you guys. If not, then please ask me. This is one of the most important things that you have to do. If you are not doing this, you are gone. You cannot do this. Understand my point? You are standing at 0. So you write 0 right here like this, and just above that, like a power or degree, you will write its distance. What distance it is storing right now. Understood my point? And from that distance to whatever new number you are going towards, you will calculate that distance plus the current distance. Understood my point? Which is equals to 4 right here. 4 is better than 1. You found a new path. So add 4 comma 1, distance comma node, distance comma node. So here now you will add 4 comma 1 in the priority queue. I hope so that this is very much clear. What it is? 4 comma 1. I said that as soon as you found a path, you add that path into the priority queue, guys. Alright? Because you are taking this. So you are adding this. You are taking this. You took this path. So you added there. Now you see you are standing at 0. You have to go to 2. And at 2 right now, infinity is stored, right? So from 0 plus how much distance is to reach to 4? So 0 plus 4, 4 distance equals to 4. You saw that on node number 2 there is infinity. So 4 is better than infinity, right? So you removed that and put a 4, nice 4 there. So you have 0, 4 and 4 right now in the distance array. This is over. You took this one also. So you took both the considerations and you have done this. The job of 0 and this is done. This is the rough thing that I am creating. Alright guys, and as soon as you found a new path, make sure to add it into the priority queue. 4 comma 2. 4 comma 2. Understood this, guys? Anybody has any doubts? Please do let me know. Now next, what priority queue will do is, will remove the shortest distance first. According to you, the distances are same, correct? 4 and 4, the distances are same. Distances are same. So now, what is its next value? Its next value is it node's value. Which one is the smaller? 1 or 2? Of course 1. So next time the priority queue will remove this, and as soon as you remove this, you removed one node, right? So now you are standing at 1 with a distance already storing at 4. Understood my point? Now you will check from 1 where all places you can go. You can go towards 0 with a distance of 4. You can go towards 0 with a distance of 4 if you check in the adjacency list. And where you can go? You can go towards 2 with a distance of 2 again. Now will you take the decision, guys? See, you are standing at 1. You are going towards 0. Now you are standing at 1, you are going back towards 0. You were standing at 0, you came from there to here towards 1 with the distance of 4, and now from 1 you want to go to back to the distance of, guys wait, my camera went off, I'll just put a button right there. Yeah, so yeah, we are back. Okay, so guys in here we were standing at 0, you came to 1 with a distance of 4. Now from 1 you are going back to the 0 with a distance of 4 again. What will happen? 4 plus 4 equals to 8. Now you see, why you want to go towards 0 again? You are not going back to 0. So it's, you see, 8 is better than 0 or 0 is better than 8. Of course, if shortest distance, 0 is better. So you will not consider this case. You will not consider this case. Let us check it out for 2. From 1 you are going towards 2. 4 plus 2. 4 plus 2, which is equals to 6. Is 6 better than, towards 2 you were going, no, is 6 better than 4 stored at 2? No, 4 is still better. So you are not going to consider this case also. So you will not do anything in this case, guys. I hope so that this is very much clear, and the job of this is done, over. Next, you did not move anything, you did not do anything, you did not find anything, so you did not add anything. Next, who is going to get deleted from the priority queue? Of course, this guy, which is the only one left here. So I removed that, and it was 4, 2. So now you are standing at node 2, and from 2, where all places you can go? This is going to be huge. So I am going to make it here. So from 2, you can go towards 0 with the distance of 4. Then you can go towards 1 with a distance of 2. Then you can go towards 3 with a distance of 3. Then you can go towards 4 with a distance of 1. Then you can go towards 5 with a distance of 6. I hope so that this is very much clear, guys, what I did here. So now you see, from 2, what was the distance stored at 2? 4. So 4 was the distance stored at 2. So if you want to go from 2 to 0, why you will go from 2 to 0 backwards? If you go backwards, 4 plus 4 will happen. 4 plus 4 will happen equals to 8. Is 8 better than 0? No. So you will not take this consideration. You will not take this into consideration, guys. You will not take this. I hope so that this is very much clear. Next, in this case of going towards 1, why you want to go from 2 to 1? If you go from 2 to 1, 4 plus 2, 6. Is 6 better than 4 in this 1? No, right? So you will not take this one also into consideration. You are not taking it. Okay, guys? Then you are going from 2 to 3. Have you visited 3 yet? No. So this is going to be the first new path you will be finding here. So 4 plus 3, how much? 4, 5, 6, 7. So you said, if I start from 2 and go towards 3, from 2 it took 4 plus 3. How much? 7. 4, 5, 6, 7. And you saw we found 7. You saw that on 3, is 7 better than infinity? Yes. So you took 7 up here, and here you accepted this one. You found a new path, and as soon as you found the new path, guys, what you will do? You will add that new path into the priority queue. So next path is 7, 3. 7, 3, distance and the node. I hope so that this is absolutely clear to all of you guys. Is that clear? Next. Now, we'll continue this one. Now you are moving from 2 to 4. From 2 to 4, if you are visited 4, no. 4 plus 1, 5. You will take this path and you will fill this 5 right here. You will fill this 5 right here. Is that clear, guys? Because you found a new path, you will add this also into here. That is 5, 4. I hope so that this is absolutely clear to all of you. Then you will go from 2 to 5. From 2 to 5, 4 plus 6, that is going to be 10. You accepted this path. Why? Because there was no path. 10 is far more better than infinity. So I stored this 10 right here. I hope so that you guys are able to get what I am trying to explain here. You understood my point, guys? Let us continue. Okay. So in here, this is the case. Now I will delete all of this and let's move on. Next. So your array is full, right? But you cannot stop here because your array, your priority queue is still not empty yet. So we need to make sure that the iterations will keep on running until the queue becomes empty, until the priority queue becomes empty. Right now, still you have the shorter path, and by the way, you found one more path. So what you will add? Here you will add 10 comma 5. Understood this, guys? Correct. Now you will check the next one. Who is the next one? Which is the smallest? Of course you have 5 comma 10. That means where are you going towards? You are standing at 4. From 4, where all places you can go? From 4 you can go to 2 with a distance of 1. From 4 you can go towards 5 with a distance of 3. 5 with a distance of 3. I hope so that this is absolutely clear to all of you guys. Okay? And the HDMI is not okay. So we are back here, guys. Okay, there is some issue with the cable. 1 minute, guys. Okay, so we are back here. Okay, so yeah, in this case, what happened? From 4 to 5, we can go with the distance of 3. So from 4 to 1, what do you want? For 4, we add 5, right? So 5 plus 1, 6. Is 6 better than 4? No. So we are not going to take this into consideration. 4 to 5 you are going. 5 plus 3, it will become 5, 6, 7, 8. Is 8 better? Is 8 better? Yes, 8 better than 10. So you will remove this 10 and you will say 8 in the place of 10. I hope so that this is very much clear. You found a new path. You found a new path. So you will add that right into the priority queue right here, guys. Okay. That is 8 comma 5 right in the priority queue right up there. Okay, guys. I hope so that this is very much clear. Okay. What we did here is absolutely clear. Okay. You took this into consideration, but you did not take any other thing into consideration. Okay, guys. Next, we'll move on next. Priority queue is still not empty. The next thing which will go is this one. That is 7 comma 3. So you see, from 3 where you can go? From 3 you can go towards 2 with a distance of 3, and you can go towards 5 with a distance of 2. At 3 already 7 is stored. So will you go from 3 to 2? 7 plus 3, which is 10. So 10 is not better than 2. We are not considering this case. From 3 to 2, from 3 to 2, from 3 to 2, will you go 7 plus 2? 9. Is 9 better than 10? 8? No. So we are not considering this case. So this got removed. Next one, 8 comma 5, 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 8 comma 5. You are standing at 5. So from 5 you can go towards 3 places. 2 with a distance of 6, then you can go towards 3 with a distance of 2, and then you can go towards 4 with a distance of 3. And guys, what is the distance stored at 5? 8. So no chance you can take 8 plus 6 distance. No, we are not considering it. You cannot take 8 plus 2 again because it is gonna become 10. And you cannot take this also because it is getting too much. None of these will accept. These are far more better values in this case also. So this is also gone. Last is 10 comma 5. Again, if we are at 5, none of the values will be taken here in this case in the consideration, and you guys will see that the while loop is empty. While loop is empty. I hope so that this is very much clear. And what are you left with? What are you left with? The answer vector is the distance array, which is 0, 4, 4, 7, 5, 10. Not 10, 8. 8. This is gonna be 8. Guys, as soon as this gets over, guys, we are going to be returning the distance array. Well, I hope so that this is absolutely clear to all of you guys. If you have any doubts, please do let me know. Now, we are going to go towards the code and we are going to see this code and try to understand this as well. So guys, this is our driver code, this is our main function. Now, because this is a solution from to the Code Ninja's Dijkstra's problem, so if you don't know about what is that, Google it on Coding Ninja's Dijkstra's problem and you will find the program. This is the solution for that program. It was taking some test cases, so this T is that test case. Will ask how many test cases you have, and then based off of those test cases we will say the vertices and edges, and then we are calculating the adjacency list like this, and then we are calling the Dijkstra's main algorithm function. Okay guys, I hope so that this is very much clear. So now here, this is the function. This function is going to return the answer vector, the distance array. So its return type is vector of type int. The name of the function is Dijkstra's, and it is going to take the number of nodes and the adjacency list with the with what is this, with the okay, the weights. Understood this guys? Okay, so this is your vertices, all the vertices. Okay, now we start by creating the priority queue, and here we have used STL priority queues guys. In session number 31 I have explained a little bit of STL concept, and for that reason I have taken priority queues. This is STL priority queues guys, and if you watch my session number 31, there I have explained how to use STL, and in that STL I have explained about how to use vectors. Just like vectors, I have already shown you the example of priority queues or regular queues. Similar to that, you can use priority queues. So he said priority queues of type pair of int comma int. Priority queue of type pair of int comma int. Int comma int means the distance, and one int is for distance and another int is for the node. I hope so that this is very much clear. And then we are going to take up the vector of the pair, and this is the comparator. Here this thing will compare all the elements, and it will only comparator here is gonna be taking up, and if I say pop, then here it is going to delete the smallest distance. Understand my point? This is the comparator, smallest distance, and then this is the vector for distance vector, which is the array here in this case. Okay, right now because on the first source index because it is gonna be 0, we are going to start from 0 to 0, it is 0. So at that particular source just put 0 distance. Okay, and then we will push that whole thing 0 comma the node, the distance and the node into the priority queue which we have created. Alright guys, I hope so that this is very much clear to all of you guys. Okay, while the priority queue doesn't becomes empty, take out the first element, that is the distance, the smallest distance, and then pop it out. And once you pop it out, go to its adjacency list and check its weight and the node distance, and if the distance plus the edge weight is smaller than the distance stored at the adjacency list for the distance array, there you put the weight if it is smaller. If it is not smaller, then do not do anything, do not touch anything in this case. I hope so that this is very much clear. And as soon as you found that, you push the new distance into the priority queue back again. I hope so that this is very much clear. And once the whole thing is done, once the whole thing is getting done, you will return the distance at the end, finishing up the iteration and doing the job as fine as possible. I hope so that this is very much clear to all of you guys. This is the code for the Coding Ninjas problem. You can try this. And yep guys, this is all about this concept called as Dijkstra's algorithm. I will pin up the code in the comment section below, and the notes will be provided into the description below for this particular concept guys. I hope so that this is very much clear. If you have any doubts, we can start the doubt session now and I can clear your doubts. Alright? Well, I hope so that you have understood this session really well. If you have any doubts, please do let me know in the comment section below guys. This is the Dijkstra's algorithm. I'll put the link of the board, the blackboard, into the description for more precise understanding this whole thing. I'll be putting this into the description below guys. The link of this board will be given into the description guys, and I hope so that you were able to understand the Dijkstra's algorithm which I have explained in today's class. In tomorrow's class we will do Prim's algorithm, and we will finish up the DSA part for this playlist. I guess so that there are enough concepts have come already, and tomorrow we will give the conclusion to this playlist right here. I hope so that this is absolutely clear to all of you guys. Clear? So let's see. No doubts, no doubts. Maddie Strange, keep going sir, you are doing great job. Thank you so much Maddie Strange. I hope so that you have understood this really well. The notes and everything will be provided in the description below guys. There is no doubts. I'll be closing up this session guys. Thank you again so much for watching this live stream, and if you have understood, give us a thumbs up. If you have not understood, tell us in the comment section below, and I'll try to solve your doubts as much as possible. Don't forget to like, share and subscribe to our channel guys, Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Also don't forget to follow us on our Telegram channel, because on Telegram channel I keep on posting all my notes and every update on the batch creation and stuff like that. So guys, that's all for this live session. I hope so that this was clear to all of you. If not, then I'll explain you that in the comment section below. Thank you so much guys. I hope so that this is very much clear, because there are no doubts. We're gonna conclude this session and we're gonna see tomorrow. Guys, tomorrow last session, 7 o'clock Indian Standard Time. Alright guys, I hope so that this is absolutely clear to all of you. This is Ashank David signing off guys. Take care, and I'll see you again in tomorrow's class.